All right, so a kite is a quadrilateral that has two pairs of congruent sides, but the opposite sides are not congruent. Okay, so two pairs of congruent sides, but the opposite sides are not congruent. So looks just like a traditional kite that you'd fly in the sky. So, so consecutive congruent sides, right? But no sides, but the opposite sides are not congruent. Okay, so this is not congruent with this. All right, and that takes out. So a rhombus has two sets of congruent sides as well, but obviously a rhombus also has opposite pairs of congruent sides, and so that's not so a rhombus is not a kite. All right, so one thing with a kite is the diagonals are perpendicular. So let's prove that here. If a quadrilateral is a kite, then its diagonals are perpendicular, right? Just like a rhombus. All right, so that's what we want to prove. So we're given that we have a kite, right? So given that ABCD is a kite. Oops, let me see. I don't know why I put given on that side there. So ABCD is a kite. And that's given. And then it gives us the two parallel sides. It says AB is congruent to segment AD, and BC is congruent to segment CD. All right, so we have that already depicted here. So we want to prove that BD is parallel to AC. All right, so let's see. So we're trying to find perpendicular. So we want to either prove that they're right angles or prove that they're supplementary and congruent. Maybe we could do that. So let's see, what's the best option here? So I think the best way to go is to say that since A is equidistant from B and D, the two endpoints of BD, that means A must be on the perpendicular bisector of BD, right? So I can say A and actually C for the same reason, right? So A and C are on the perpendicular bisector. Okay, so A and C are on the perpendicular bisector of BD. And we know that by the converse of the perpendicular bisector theorem. Okay, so it says if a point is equidistant from a segment's endpoints, then it must lie on the perpendicular bisector of that segment, right? Okay, so now we essentially have it, right? We just have to say that AC is the perpendicular bisector. So AC is the perpendicular bisector, right? If A and C are both on it, then AC itself must be the perpendicular bisector of BD. All right, and the reason why is because through any 2 points there's exactly one line, right? So if A and C are both on it, then they must be on the line that is the perpendicular bisector, right? So you can say through any 2 points there's one line. You could say 2 points determine a line. So also just say 2 points. So if 2 points, then exactly one line. Okay, and then if it's a perpendicular bisector, that means AC must be perpendicular with BD by definition of perpendicular bisector.